gonna be solving the week 7 chem AMS quiz. And now let's start. Which of the following is the electron configuration of sodium atom? So it has an atomic number of 11, meaning we know that the first shell will only be able to be filled up with 2, second shell maximum 8. When you add these 2, it's 10. To reach 11, you have to add 1 more. This is your electronic configuration. Now let's move on. Which of the following arises from equal sharing of 2 electrons? Your keyword here is sharing. You see the word sharing? Covalent. It can't be metallic. It can't be ionic, because ionic doesn't have sharing. And it can't be electron bond. It has to be covalent if there's the word sharing. Okay, so know how to draw the electron dot diagram for ions. So the atomic number of magnesium is 12. Now we know that we can write the electronic dot diagram for ions in 2 different ways. One, where you take the ion, you fill it out with a full shell, and then you put the brackets and the charge. One, where you just put the empty shell with the brackets and the charge. Because magnesium, it's in group 2. Magnesium is gonna lose 2 electrons to become stable. If it loses 2 electrons, then its shell, the next shell after it, is full, or the shell that has the last valence electrons is empty. This is what they mean by these 2. And you have to put the brackets and the 2 plus to show how many electrons does it lose. Okay, so which of the following are the cross dot diagrams for the given compounds? So what this is asking you is which of the following are dot cross diagrams. This is a dot cross because there's actually dots and there's an intersection point. Here's 2 intersection points, 3 intersection points. These are obvious dot cross diagrams, but then you're gonna get something like this. This is why you need to actually know what you're looking at. H has 1 electron to give, and it has 1 electron overall. F has 7 valence electrons. It needs 1. So they're going to share 1 from F and the X from H. And then now you have sulfur. Sulfur is in group 6. So it needs 2. Each hydrogen can give 1. So it is bonded to 2 different hydrogens, each which give you 1 X. Now both are satisfied. Hydrogen has valence electrons 2 like helium. Sulfur has 8 valence electrons. Here, Na, I, 2 minus. If it's 2 minus, it means you need 2 Nas, you need 2 pluses to cancel out the 2 minuses. Here there's 1 plus and 2 minuses. You can't. You need to add another Na to it, and then it will be correct. But here now, as it is now, it's wrong. Here you have nitrogen. Nitrogen needs 3 electrons to become stable. So you have 1 shared with hydrogen, another shared with hydrogen, another shared with hydrogen. Here you have Mg2 plus and you have 2 minuses, because F minus and F minus to cancel out that 2 plus. So this is correct. A single covalent bond formed between 2 atoms where only one of them shares both electrons of the bond with the other is called a dative bond. This is a definition of a dative bond. You should memorize it. Okay, so here it's asking you know how to draw, the atomic number of phosphorus is 15. What the hell did I know? Anyways, the atomic number of phosphorus, 15. Select the electron dot diagram of phosphide ion. So we know that phosphorus is 15. So let's write down its configuration. 2, 8, 5, right? So if the last shell has 5, we need 3 more. So P has 1, 2, 3, 4, 5 on its outer shell. So we need 3 more to connect to each one of these. So you're going to draw either an empty dot or a cross beside each one of these. And then you have to add, of course, the charge, 3 minus. So if it's 3 minus, you know you need to add 3 x's. And here, this one is 3 minus. You're going to say, oh, why didn't they choose this one? Be careful. When you write it, first, this is how you write electron dots. You have to write 1, 2, 3, 4, 5. So you have to have at least one black dot on every square shape of on every corner of P. You have to have at least one, and then you start adding more, going clockwise, counterclockwise, doesn't matter. Okay, next question. It's asking us correct electron dot diagram of a neutral atom. So look here, oxygen, we know it's 2 and 6. So we need to find oxygen, the one with 6 valence electrons. 1, 2, 3, 4, 5, 6. And this is a correct drawing, because look, you have 1, then 2, then 3, then 4, and then 5, and then 6. So this is a correct drawing because all the electrons are drawn صح, or correctly. Boron is 5, so 2 and 3. So then you must have only 3 valence electrons. So 1, 2, 3. Doesn't matter where you put them, but as long as you only have 3 and no double bond or no double electrons. Now nitrogen has 7, so it's 2 and 5. So nitrogen should have 5 electrons surrounding it. You're gonna say, oh, 1, 2, 3, 4, 5. Oh, let's choose it. No, because it's drawn on wrong. Nitrogen, you need to do this. 1, 2, 3, 4, 5. You need to do it like this. You can't have any side with no electrons on it. You have to draw it like that. You have to fill out all the sides, then start adding your second or third electrons. Well, second, no, not third. But you get the picture. So this one's wrong. Now, synonym 34. So 2, 8, 8, 8. Wait, so it's 32 minus 2, so 2 and 4 8s. I'm assuming. Wait, 8 times 4, 32, 32 plus 2. Yeah, I think this is its electron dot. Yeah, so I just checked, it is. Which means that your last part should be filled with, what's it called? 8 electrons. So 1, 2. Oh wait, sorry, that's the wrong way to draw it. 1, 2, 3, 4, 5, 6, 7, 8. That's how it should be drawn. SE. So this is definitely not like that, so this is wrong. And this is an yeah, it's wrong. Because you should know how they're supposed to be drawn. Okay, select the molecules that have coordinate covalent bonds. These 2 examples should be memorized alongside the ones in the notes. Memorize them because, yeah, they're not there's no real way of actually knowing. Okay, for this is really easy if you just focus. So magnesium chloride, magnesium, and you have Cl. Magnesium's in group 2, Cl's in group 7. Group 2, they become +2, and group 7 become -1. So now we cancel this, and now we cross. We give the 2 to the Cl and the 1 to the Mg, so it becomes MgCl2. You give the 2 to the Cl and the 1 to the Mg. Let me do more examples so you can understand better. Potassium sulfide. Potassium is K in group 1. Sulfide is S in group 6. So K needs +1, S needs a -2. Or technically this is Mg plus, yeah, K plus S minus, S2 minus, yeah. So now what we do is you give the 2 to the K, the 1 to the S, so it's K to S. Now let's continue. Aluminium oxide, Al 3 plus, O 2 minus. These 2 you have to have memorized. Al is, especially because it's a transition metal. So Al3 plus O2 minus, you give the 3 to the O, 2 to the Al, so you're going to end up with Al2, O3. Calcium nitride, Ca is in group 2, so it's Ca2 plus. Nitride is N3 minus. So again, cross Ca3 N2. Ca3 N2. Now for the second line, it's way easier. We're gonna forget this popped up because it pops up whenever I double click the screen by accident. Bromide ion, bromide is in group 7. Or wait, yeah, bromide is in group 7, so it'll lose 1, so it'll become minus. Because it gains 1 electron, so it becomes minus. O is in group 6, so it gains 2 electrons to become stable, so it becomes 2 minus. Calcium is in group 2, it needs 2 electrons, it loses 2 electrons to become stable, so Ca2 plus. Boron is in group 3, so it will lose 3 electrons to become stable, so B3 plus. You have to look at the group numbers for this row you have to cross. Now, moving on. So here they're asking you for electronic configuration of some of the following ions. This is 13 and 3 plus. So what this means is you need to draw the configuration, so 2, 8, 3. And since it's 3 plus, subtract 3 from the last number, remove it. You're going to be left with 2A. Now F9 minus, so 2, and then 7. Minus means minus 1. So what you do, if it says minus 1, you add 1. So again, 2, 8. These numbers for if whenever you have an ion, this number will always be like one of the group 8 elements. Always. Moving on. Okay, so for this question, element X reacts with magnesium to form an ionic compound where it's MgX2. Which means if you crossed it, Mg, we know it has 2 plus, and X gave whatever it has here to Mg. Since Mg has no subscript here, then this had plus or minus 1. It had, plus or minus 1. Most likely minus 1 since it's Mg, so minus 1. So Mg gave it the 2, and this took the 1. So if this is minus 1, then it probably had something like 2, 8, 7, because you do the number of valence electrons minus 1. Now let's see. X has a high tendency of forming -1, while Y has +2. So any element that forms -1 ion is like the group 7 elements. All group 7 elements ions are, or wait, no, not all, but like all group 7 elements, they end with the number 7. So if it's -1, then it has to be group 7, meaning that the valence electrons of whatever electronic configuration you choose should end with 7. +2 means that it's in group 2. So whatever option you choose must have valence electrons or the last number to be 2. Now, moving on. By the way, guys, some of you might be asking, like, how do you find out how many does it lose? If it's in group 1, it has +1. Group 2, +2. Group 3, this is 2, +3. Group 4, we don't know because these are like the confusing ones. So we're going to forget them for now. Group 5, -3. Group 6, -2. Group 7, -1. This is how to know your charges. Anyways, hydrogen fuel cells work like batteries, but they do not run down or need recharging. What the gas is reacting? O2, H2, and they produce H2O. Memorizing, it's from the topic, really easy. Okay, so this is just asking you which of the following are the harmful gases produced by the catalytic converters. Carbon monoxide, nitrogen monoxide, and if they gave you a nitrogen dioxide in the options, it is also considered correct. And here we have to use the gamma rule, so Cl2, or actually no, it's F2, then Cl2, then Br2, then I2, then F minus, Cl minus, Br minus, I minus. So Cl2 and and Cl2 as your atom and I. You have to make anything that forms a gamma like this is correct. If it does not form a graph like that, it's not. So Cl2, I, so then it's gonna form I2 and Cl minus. Forms I2 and Cl minus. So this is correct. So it's spontaneous. Now I2 and Kf. So I is the one with the charge. So I2, Kf forms F2 and I minus. Is this? No, it's definitely not. So this is wrong. Non-spontaneous. So this is wrong. Br2 and KCl. Br2, KCl minus. Again, no. This is wrong. Non-spontaneous. Okay, for this type of question, again, hydrocarbon, you put your mass of hydrogen, which is 700 minus 75, which is 25, over mass of carbon, which is 75, and then you put the mass of carbon over its molar mass, which is 12, and then you're gonna put them all in your calculator. You're gonna get 4. So this is the number of hydrogen, and this is the number of carbons. So CH4. And if you get a decimal point, first of all, multiply it by 2. If you still get a decimal point, remove the 2 and multiply the original number by 3. If you still get a decimal point, multiply it by 5. Impossible after multiplying it by 3 of these things, you still get decimals. And when I say decimal point, I mean anything that's not 0.1 or 0.9. If it's 0.1, round down. If it's 0.9, round up. Like, don't try to find, like, if it's a 0.9 decimal, just round up. If it's a 0.1, just round down. And by the way, if you multiply the decimal by 2 and it works, do not forget to multiply the C by 2 as well. Don't forget to multiply this by 2 as well. If you're multiplying this by 2, don't forget to multiply this by 2, or by 3, or by 5, whatever you worked with you at the end. Here are RGR. So you have 0.8 moles, and then you have 2 Al2O3, then it's 2 into 27, 2 times 27 plus 48, which is O3. It's gonna give you a number, whatever, multiply this by this, and then divide them by 4, you're gonna get 40.8. Percentage yield. What we do here is we need to find the tons and the theoretical yield. For theoretical yield, you use RRGR. So let's start. So you have 0.5 tons, so 0.5 times 10 power 6 of over, this is 4 because it's 2H2, and then methanol produced, which is actual, is 3 tons. So 3 times 10 power 6. Then over theoretical, which we're gonna find, times 100. That's your formula. Then, so you're gonna multiply this by CH3OOH. I don't want to find this. Oh my gosh. Anyways, 4 plus C is 12. 4 plus 12, 16. 16 plus 16, 32. So you cross multiply this by this, then divide it by that. You're gonna get your answer to be 4 tons. Then, after you get the 4 tons, or you're gonna get 4 times 10 power 6, that's in grams, so 4 tons. You're gonna do 3 times 10 power 6, which is your actual yield over what you found, times that by 100, 75%. And that is it. Thank you for watching. Have a good day. Bye.